Hi everyone, so this is just going to be a quick little video where I share some surface mount soldering tips with you. This is a way to do it really cheaply. It does take a bit more time, but it's good if you're just doing some simple prototypes which don't have like very fine pins on some of the connections. Like for example, this board here. This technique would not be suitable for things like that. A 64 pin chip, it's probably just not going to be happening without a lot of work. So the first thing you're going to need is the right kind of solder paste. So this is what I'm using. This is mechanic solder paste XGZ40. Now I did use a different kind that was in a small tub and it was just an absolute nightmare to work with. This stuff seems to be a lot better. So it comes in this syringe, and the first thing you want to do to the needle is cut it down quite a lot, make it as short as you can really. And the reason for that is because it's very difficult to push the paste through the needle. So if you shorten it down, it makes it much easier. And as you can see, I've already started on this board. So what you're doing is you're just squeezing small amounts of paste onto each pad, pad by pad really, making sure you're not putting too much on. It's just a tiny little bit you need. Try not to overlap stuff as well. For example, this 8-pin chip here, you could just sort of drag it like that, but it's a technique that you'll sort of learn and get used to. So it's just like that until every pad is covered, and then you'll just use tweezers to pick and place your components, and then I'll show you the next step from there. Another important thing to note is when you're squeezing the paste out, you want to sort of just try and dab it onto the pad as well, because sometimes if you don't, when you go to reflow it, I had a problem where it didn't actually stick to the pad. It stuck to the chip but not the pad, and then I had this high resistance connection. So this is one I prepared earlier. This is what it's going to look like, and I had a high resistance connection on the input pins of this chip, and for some odd reason the 12-volt supply rail on this DC converter, that's what this is, it's a 12-volt and 5-volt DC converter, I was getting like 3.5 volts out of it, and that's because there was a quite high resistance connection on the input pin of this chip. So another idea to help make things a bit easier is when you're going through your bill of materials. So in Easy EDA and LCSC, you would go to export BOM, which stands for bill of materials, on Easy EDA, and the list will come up. So then you just look for the part number on the part that you received after you've ordered it, and then just write down what component that corresponds to just on each bag, and then it makes the pick and place process a bit easier for you. Okay, so now it's time to pick and place. So I've just got these kind of tweezers here. It's a good type to use. And so this is R3 which I'm trying to place. So we're just grabbing the component and placing it down. You just set it on top of the solder blobs and sort of push it in a little bit. And there we go. Here's this little inductor going on. It's a good idea to try and steady your hand as much as possible when you're doing this. So there we go. Inductors are actually very hard to get a hold of just now for some odd reason. I thought there was meant to be a chip shortage, not an inductor shortage, because to actually find the correct current rated inductors for this board, well, it was impossible. I couldn't do it. So I actually had to use inductors which were of a lower current rating, which is quite unfortunate, but as you can see, we're placing stuff quite well. Okay, what I have here is a frying pan, and I'm going to turn it upside down over the smallest gas hob and just place it like that. And what's going to happen is I'll turn on the gas and just heat it up so that, like, if you were to flick water on it, you just hear it like sizzling, and then place the board on. So I'm going to do that now. Okay, so now we're up to a decent temperature, so what I'm going to do is I'm just going to take the board and just place it sort of just away from the centre, because the centre is probably going to be just very slightly colder because of just the shape of the gas flame and all that. So that's the board placed on now. So all we're doing now is just waiting. What will happen is the flux is going to start melting, solder paste will start melting, and we're just waiting until all the solder starts flowing, and that could take about a minute or so, but you've just got to keep a good eye on it. Well, we've already got a part flowing now. There we go. Yep, there we go, that's everything flowing. That's about... Can't leave it like this too long as you'll damage the ICs due to the heat. But I really do like this way of doing it because the heat's coming up from the bottom, so you're probably a lot less likely to damage stuff. I'm just checking everything to make sure it's good. And there we go. I think that's a reflow done. So lifting the board off and just placing it to the side to cool. So here's the end result, and as you can see it looks neat enough. No sort of flux residue or mess. So the next stage is just to solder on the through hole components, but I'll show you how I do that. So when it comes to the through hole stuff, we've got this capacitor here. So what I do is I just place a component, and then I just make sure it's I just hold it with my finger and make sure it's sitting properly, and then I cut the legs off like that before I've soldered it. Then what I'll do is I'll get actually my solder paste and then just put it on each pad. So we'll just do that now. Just put a good sort of blob in there. And because it's solder mixed with flux, it's actually very easy to solder that. So I'll just bring the soldering iron to it now. Probably could have done with using a bit more solder there, but you can always add more later. So that would be that component soldered. And that's how you do it. Okay, now it's time to power up and test. So here goes. Let's try to get it plugged in. Right. So there we go. Both LEDs are on anyway. That doesn't necessarily mean it's working properly though. So I'll just get my multimeter, see what our voltages are. So 12 volts giving us 11.949, which is a tiny little bit too low, but for the application I'm using this for, that's fine. And our 5 volt, we get 5.026 on this particular board, so that's a bit better than the last one. So from what I can see so far, this little board works perfectly. So what this board is actually getting used for is in the motor controller that I'm developing. So it's generating the 12 volt and the 5 volt that the board needs to function. The 12 volt is for the gate drivers for the MOSFETs. The 5 volt is just running the Hall sensors and stuff, and then that will be dropped down to 3.3 volt using a linear low dropout regulator which powers the main processor.